Solving water scarcity, the power of desalination. Solving water scarcity, the power of desalination. Water, the essence of life, sustains every living being on our planet. However, despite the Earth's abundant water resources, water scarcity has become an increasingly pressing global challenge. As population growth, climate change, and industrialization continue to strain available freshwater sources, innovative solutions are imperative. Among these solutions, desalination has emerged as a powerful tool to alleviate water scarcity and ensure a sustainable water future. Understanding water scarcity, a global crisis. Water scarcity refers to the shortage of accessible fresh water in relation to the demand for it within a region. The United Nations predicts that by 2025, nearly two-thirds of the world's population could face water stress, exacerbating health, economic, and environmental challenges. Desalination, a technological marvel. Desalination, the process of removing salt and other impurities from seawater or brackish water to produce fresh water, has gained prominence as an effective means of augmenting water supply. The technology behind desalination is not new. Ancient civilizations practiced rudimentary forms of distillation. However, modern desalination methods have evolved into sophisticated processes that offer substantial benefits. Two primary techniques dominate contemporary desalination: reverse osmosis and distillation. Reverse osmosis involves pushing water through a semi-permeable membrane to separate salt and impurities from fresh water. Distillation, on the other hand, heats seawater to produce steam, which is then condensed back into fresh water. Both methods require energy, with advancements aiming to make the processes more efficient and environmentally friendly. Harnessing the power of desalination. Desalination plants are being established across the globe to address water scarcity issues. Countries like Saudi Arabia, the United Arab Emirates, Israel, and Australia have already embraced desalination on a large scale, with notable success. For instance, Israel has transformed its arid landscape into a thriving agricultural hub using desalinated water, ensuring food security and economic stability. Desalination has also made significant contributions during times of crisis. In California, the Carlsbad desalination plant became operational in the midst of a severe drought, providing a drought-resistant source of fresh water to the region. Similarly, the Gaza Strip, facing extreme water scarcity, relies on desalination to meet its water needs and improve public health. Challenges and considerations. While desalination presents a promising solution to water scarcity, it is not without challenges. One of the primary concerns is the environmental impact of the process. Disposal of concentrated brine, a byproduct of desalination, can harm marine ecosystems if not managed properly. Additionally, the energy requirements of desalination can contribute to carbon emissions, unless renewable energy sources are used. Economic considerations are also significant. The initial capital investment required to establish desalination plants can be substantial. However, as technology advances and economies of scale come into play, the costs are gradually decreasing. Furthermore, the benefits of a reliable freshwater supply and reduced dependence on erratic rainfall can outweigh the upfront expenses. Innovations in desalination technology. To address these challenges, researchers are actively working on innovative solutions to make desalination more sustainable and cost-effective. Breakthroughs in membrane technology have improved the efficiency of reverse osmosis, reducing energy consumption and minimizing the environmental impact. Additionally, research into forward osmosis, a process that uses naturally occurring osmotic gradients, could potentially reduce energy requirements further. Integration with renewable energy sources, such as solar and wind power, is another avenue for enhancing the sustainability of desalination. By powering desalination plants with clean energy, the carbon footprint associated with the process can be significantly reduced. These advancements align with global efforts to transition towards a low-carbon, sustainable future. Local and global partnerships. Addressing water scarcity through desalination requires collaboration on multiple fronts. Governments, private enterprises, and research institutions must work together to ensure the successful implementation of desalination projects. International cooperation can facilitate the exchange of knowledge and best practices, enabling countries to learn from each other's successes and challenges. In regions where desalination might not be the sole solution, integrated water management strategies become crucial. These strategies consider a combination of desalination, wastewater treatment, rainwater harvesting, and efficient water use to optimize water availability and minimize waste. The road ahead: desalination for all. Desalination stands as a beacon of hope in the fight against water scarcity. With the right investments, technological advancements, and sustainable practices, desalination can provide a reliable and secure source of fresh water to communities around the world. As the global population continues to rise and climate change impacts intensify, embracing desalination could mean the difference between a water-scarce future and a water-secure one. Governments, industries, and individuals must recognize the potential of desalination and actively support its implementation. Additionally, public awareness campaigns can educate communities about the benefits and considerations of desalination, fostering a sense of responsibility towards water conservation. Balancing progress and conservation. While the benefits of desalination are clear, it's important to strike a balance between progress and environmental conservation. The environmental impact of large-scale desalination can be significant if not properly managed. Efforts to mitigate these effects must include careful site selection, monitoring of marine ecosystems, and responsible disposal of brine byproducts. Innovative approaches are emerging to address the environmental concerns associated with desalination. One such approach is the utilization of solar desalination, which harnesses solar energy to power desalination processes. This not only reduces carbon emissions but also lessens the strain on traditional energy resources. By combining renewable energy sources with advanced desalination technologies, we can achieve a more sustainable water supply without compromising the health of our planet's ecosystems.